Is given that a small sphere of mass m is dropped from a greatest height. After it has fallen 100 meter, it has attained its terminal velocity and continues to fall at that speed. The work done by air friction opposite the sphere during the first 100 meter of fall is. So actually here we are going to compare the value of work done by air resistance in the first 100 meter and work done by the air resistance in next 100 meter. So if an object is dropped from a particular height, let's say from here, and initially we know that the force is acting on this one are nothing but the weight of this object mg, and next one we can take it as nothing but the viscous force, which we can take it as fe. And this viscous force, we know that this is 6 pi eta into r into v, and we know that this viscous force is not a constant. This viscous force is varying with respect to the value of velocity. So as it is moving down, its velocity will increase and viscous force will increase, and then it is going to attain a maximum velocity, which is known as nothing but terminal velocity. And when it's attained terminal velocity, this viscous force is maximum. So we can say that the viscous force in the after attaining terminal velocity is more as compared to viscous force before attaining that terminal velocity. So for this displacement, the force is more, and for this first 100 meter displacement, the force is less. So definitely we can say that work done in the second situation is greater than work done in the first situation, or for the first 100 meter. So it is given that the work done by air friction during the first 100 meter of fall is greater than work done by the air friction in the second 100 meter. No, second 100 meter is more as compared to that of first 100 meter, because there the value of friction is more, or because it's more attained maximum velocity. So and this viscous force is directly proportional to velocity. So we can say that is less than the work done by the air friction in the second 100 meter. Is it equal to 100 mg, and it's greater than 100 mg? We cannot say that it is equal to 100 mg or greater than 100 mg, because we can say that it is less than 100 mg, and because once it is attaining terminal velocity, then the work done may be by the gravity. So we can write over here this work done will be equal to for work force into displacement. Force is mg, and if it is displaced by a distance 100 meters, so work done in the second situation we can take it as 100 mg if the forces acting on this one are only weight and that viscous force. So definitely the work done in the first situation will be less than this. So the most appropriate answer is less than the work done by air friction in the next 100 meter.